7th graders, go ahead and take out your Unit 3 note packet. The other lesson, we worked on filling in a graphic organizer at the beginning that had keywords and phrases for the 4 basic operations in math: add, subtract, multiply, divide. Today we're going to apply those keywords to a problem-solving strategy called marking the text. So in your note packet, find your 3.4 real-life application with fraction notes. And please know that this is a lot of space. You're not going to be having too many things to write down. I love this, and I think you can totally relate to this. Math, the only place where people buy 60 watermelons, and no one wonders why, right? You read those in these math story problems. Who's buying 60 watermelons? Why? Just a little bit of humor for you today. Our goal is I can use rational numbers in real life applications. That is our goal today. And we're going to use the marking the text strategy. So let's talk about that. Let's refresh our mind. You have used marking the text since you were a 6th grader, if you were here with us last year. And so just a reminder, marking the text is an avid strategy that you can use when you read any passage. In math, our passages are not nearly as long as they can be in other classes, but we can still use strategies like marking the text to help us be successful. Today, you're going to be reminded of the steps for marking the text when working through real life application problems, our story problems. So I break it down to 4 steps, and really 1 and 2 you could combine, so it could be 3. The first step is to box in the question. What are you being asked to solve for? What are you being asked to find? Ask that question to yourself. Take that and write it in a sentence. Change it from a question to a sentence. Then go back and read sentence by sentence and circle any keywords or phrases. And that's where you're going to use this graphic organizer. Now, are we going to house all the keywords and phrases for add, subtract, multiply, divide in here? No, but it's a starting point. Then we're going to underline any key numbers and labels that go with those numbers. Because whenever we're dealing with real world problems, we want to label our answer. Something else to note before we move forward is, since these are real world problems, if our answer ends and we get an improper fraction, this is when we want to change that to a mixed number. And I will do my best to remind you of that as we're working through some practice problems. Before we move on, let's go ahead and let's write those marking the text steps down in our 3.4 notes underneath the word examples. There's nothing you need to write down with this problem right now. We're just going to simply mark the text and get it prepped and ready to solve. Over the weekend, you decided to train for a triathlon that you will participate in next month. You rode a bike for 3.5 hours, swam for 2/5 of an hour, and jogged for 1 1/4 hours. How many total hours did you exercise this weekend? With marking the text, we want to start by boxing in the question. So what am I being asked to find? That's what I'm going to box in. How many total hours I exercised this weekend. Then I'm going to take this question and turn it into a sentence. So I exercised blank hours this weekend. Right? Now, this tells me that what I need to look for above has to be labeled hours. And sometimes story problems put values in there that really have nothing to do with the problem. So we just want to be mindful of that as well. Next, we're going to look for keywords or phrase that tells us whether to add, subtract, multiply, divide. To do that, we're going to go line by line. Maybe in previous classes where you've marked the text, you've actually numbered your paragraphs. And you might go, Miss Clover, we're not doing that in math. No, because we already have a lot of numbers going on and our reading is such a small amount. So I don't number any sentences. You could if you wanted to. We're going to start with the first one here. Over the weekend, you decided to train for a triathlon that you will participate in next month. Any key operation word or phrase there? Nope. You rode a bike for 3.5 hours, swam for 2/5 of an hour, and jogged for 1 1/4 hours. Wow, it's listing a lot of the activities I did and the length that I did them for. That is going to help me answer my question on here, but no key operation word yet. How many total hours did you exercise this weekend? There it is, my friends. In our previous lesson, you wrote down some keyword and phrases for add, subtract, multiply, and divide. Now, we really want to pay attention to whenever we see the phrase how many, what is how many defining, right? In here we have how many total hours, total. You can also see under the add box that total is there. We're going to be adding all of the hours together to get a total. So my key phrase is how many total. Next, with marking the text, we underline key numbers and their labels. Well, my label here is hours, right? That's what my number is going to be labeled that I find. So let's go and let's look for, right here, it says you rode a bike for 3.5 hours. There's a length of time. Swam for 2/5 of an hour and jogged for 1/4 hours, right? How many total hours did you exercise this weekend? I'm going to be taking those, I'm going to be adding them together. So 3.5 plus 2/5 plus 1.25. And that's going to give me the total number of hours that I exercised this weekend. Let's look at another problem. Again, nothing you need to write down right now. Just talk out loud as I'm working through this problem with you. Mia is working on a project. Each project requires 3.5-foot boards. If she has 28 feet of board, how many projects can she make? Marking the text always gets us started, and that's what I like about it. I don't just come to a halt, like I don't know what to do. I can move forward because I have my steps with marking the text to complete. What am I being asked to find here? Let's box it in. How many projects she can complete. Next, let's take this question and turn it into a sentence and put a blank for the number that we're trying to figure out. How many projects can she complete? Mia can complete blank projects, period. So now I know that my label here is referring to projects. Let's go line by line and let's look for some keywords or phrases that are going to tell me what I need to do. Mia is working on a project. Awesome, Mia. Nothing there that I'm going to circle. Each project requires 3.5-foot boards. If she has 28 feet of board, how many projects can she make? Each project requires. I'm going to go back to our keywords that we wrote down from the other day. Each group has. You also have each over here in multiplication, each group. But here we already know each group has. Each group has to have 3.5-foot boards. So each project requires is your key operation phrase. So how many of these can I get from this? Each project requires, I want to know how many times does 3.5 go into the total length here that I have. So it is a division problem. Next, with marking the text, I need to underline key numbers and their labels. So here we have our 3.5-foot boards that we want to get and the 28 feet of board that we have. So we want to know how many of these we can get out of this. So our division problem is 28 divided by 3.5. This will tell us how many of the projects, because this represents the projects, we can get from the total feet of board that we have. Let's do another problem. Again, there is nothing you need to write down yet. All you have in your notes so far are the marking the text steps. Don't worry, we'll be adding a little bit more in just a few moments here. Here's our next problem. You work in the bakery at Cub Foods. Throughout the day, you sell 2/5 of all the donuts that you made that day, leaving 3/5 left. If your boss tells you that you can take home half of the remaining donuts, what fraction of the donuts will you be taking home? What fraction of all the donuts, will you be taking home? So marking the text, we're going to start by boxing in that question. What are we being asked to find? What fraction of all the donuts we get to take home? Now, my box is coming in kind of part way through something. So it says here, if your boss tells you that you can take home half of the remaining donuts, what fraction of the donuts will you be taking home? So when it comes to my sentence, I'm going to make sure that I put in there that it's the remaining donuts. I will be taking home blank. This is going to be a fraction, right? What fraction blank of the remaining donuts? I always think as clear as I can be in my sentence here, it helps me when I'm trying to figure out what I'm doing up here. Next, I'm going to look for keywords or phrases. I am trying to figure out what fraction of the remaining donuts I get to take home. So you work in the bakery at Cub Foods. Nothing there. Throughout the day, you sell 2/5 of all the donuts that you made that day, leaving 3/5 left. Okay. Left, that tells me subtract, right? If your boss tells you that you can take home half of the remaining donuts, what fraction of the donuts will you be taking home? Half, this is what I'm trying to figure out. I'll be taking home blank of the remaining donuts. So this left right here doesn't really tell me. I'm looking for a fraction of the remaining donuts that I get to take home. I get to take home half of the remaining donuts. When you're taking a number of another number, the remaining donuts is up here, 3/5 left, right? I could have said 3/5 remaining. When you're taking a number of another number, you're multiplying. So this is a multiplication story problem. Next to marking the text, let's underline those key numbers and their label. Here it's going to be fractions, and I'm only looking for fractions or numbers pertaining to the donuts that are left. So throughout the day, you sell 2/5 of all the donuts that you made that day. This is not helpful because they're gone, leaving 3/5 left. This is helpful. These 3/5, I get to take home half of them, right? Half of the remaining donuts. So this is a multiplication problem. 1/2 times 3/5. An order with multiplication doesn't matter. Commutative property says we can put a half first or we can put 3/5 first. So that doesn't matter. I just walked through 3 problems where I modeled marking the text to get them set up, ready to solve. I now am gonna have you write one problem down in your notes. We've already marked the text, you're gonna mark it in your notes, and then we're gonna solve it together. Remember, marking the text is a strategy, and I like it because it gets me moving forward in story problems. A lot of times I can read a real world problem and I'm like, So marking the text gives me those steps that I can follow. I'm gonna start by boxing in what I'm being asked to find, which is that question. I'm gonna write a sentence and put a blank for my answer. I'm gonna go line by line and I'm gonna look for key operation words. Then I'm gonna go line by line and look for numbers that pertain to what is in my sentence and underline them with their label. Again, it's just a strategy. Few reminders though. We are doing real world problems. We need to make sure that if the answer that we get ever is an improper fraction when we're done doing all the math, this is when we need to make sure that we turn it to a mixed number. Remember, improper fractions are easy to work with in math class. Mixed numbers are a lot easier to understand in the world. Here's what I want you to do. Underneath your marking the text steps in your notes, I want you to write this. I'm gonna go through and we're gonna do one problem in our notes right now. We already did our work on this problem. Now let's actually figure it out. Go ahead and write down this story problem and mark the text like we did here. Pause the video, and when you're ready, come on back and let's solve it together. So remember, Mia wants to know how many projects she can get out of the 20 feet of board that she has. So we have 28 divided by 3.5. Now, order with the division is really important, right? 28 divided by 3.5 is very different than 3.5 divided by 28. So always think about what is your whole here. And then you can ask yourself, well, I want to know how many times this goes into this. Sometimes asking those questions can be helpful when setting up a problem. So when we are dividing and there are fractions involved, first, we're going to make anything we need to improper. So I'm going to change 28 to 28 over 1 divided by 3.5. I'm going to do the Texas. So 2 times 3 is 6 plus 1 is 7. So I have 7 halves. Then I'm going to remember my 3 words. Keep, change, flip. Yeah, that's the action. Keep that first fraction, 28 over 1. Change division to multiplication and find the reciprocal. Flip that second fraction, 2 7s. Now it's multiplication, so we simplify before we multiply. Take every numerator to every denominator. This is already done. 28 and 7, they share a factor. It's 7. 7 divided by 7 is 1. 28 divided by 7 is 4. 2 and 1, I'm done, there's a 1. 2 and 1, I'm done, there's a 1. So here we get 4 times 2 is 8. 1 times 1 is 1. Now we never leave a fraction like this when there is a 1 in the denominator. And also a reminder, we are dealing with real world problems, so we're not going to leave our answers in improper form anyway. We're going to put them in mixed number form. So Mia can complete 8 projects. she can get 8 groups of 3.5 out of this board.